These are the solutions to our practice multiple choice midterm. So what's going to happen on this video is I'll be stopping at several spots where you'll have problems to do. So I'm going to go over, explain them, and then you'll practice a couple extra ones. First one, simplifying this. Square root of 20. We could break it down to 4 and 5. 4 breaks down to 2 times 2. So I can take out a 2. I get 2 times the square root of 5. 45 is 9 times 5. 9 is 3 times 3. I could take out a 3. That becomes 3 root 5. So if I'm going to combine square roots by addition, they have to be the same root. So I get 2 root 5 plus 3 root 5. That equals 5 root 5. Simplifying an expression, that is a division. You cannot take 50 divided by 10 and make this square root of 5. What I need to do is simplify square root of 50. So a couple different ways you can do it. One way, break it down like we did before. 5 times 10. 10 breaks down to 5 times 2. I could take out a 5. Left hand side is 2. So I get 5 root 2 divided by 10. Then I reduce it. Or you can also do square root of 50. Realizing that square root of 50 is the square root of 25 times 2. Square root of 25 is 5. 5 root 2 over 10. 5 and 2 will reduce to square root of 2 over 2. Answer there was B. Okay, for the next one, we have the square root of x cubed. Well, if they don't put anything in the square root, that index right here is a 2. They don't show the 2 there. You have to put that in yourself. So writing this as an equivalent expression, I have x raised to the third over 2, x to 3 halves. If you go to evaluate 8 to the 2/3, you're going to have to do this without a calculator. The test is without a calculator. I'm going to do the cube root of 8. That equals 2. 2 squared is 4, so my answer is 4. Okay, this is the first break. You'll have some problems to do right here. Okay, next part of the test, we're looking at factoring. Okay, first is factoring out common factors. Our first step on factoring. So I want to see what I can factor out. I can factor out an 8, goes into all those. I look at my x's. I have x cubed, x squared, and x squared, so I have at least x squared in each one. I have a y squared, and a y. I could take out a y for each one. So I would be able to factor out 8x squared y. Now if I had to figure out what's left over, well, 8x squared y times x will give me 8x cubed y. Here I took out 8, so left with 2. I took out both of my x's and one of my y's. If you take out everything, you're left with 1. Factoring this kind of problem, 2x squared minus x minus 6. Put 2x squared into the box, negative 6. Multiply those together, I get negative 12x squared. I need two numbers that multiply to give me negative 12x squared, but add to negative 1x squared. Well, if I use negative 4 and 3, so negative 4x and 3x, these two will add up to negative x. Then I can factor out 2x from here. 2x times x gives me 2x squared. This becomes negative 2. 2x times negative 2 is negative 4x. X times 3 is 3x. Then negative 2 times 3 is negative 6. That kind of acts as a check to make sure you did it correct. So my factors are 2x plus 3 and x minus 2. So C and D. Okay, next factoring one. This is special factoring one, difference of two squares. So if you have a perfect square minus another perfect squares, it's going to factor to this term times itself is going to be 3x times 3x gives me 9x squared. Then to get negative 16, I have 4 and negative 4. And what happens is the middle terms cancel. 12x, negative 12x. They cancel each other out. And that's why this factors to 3x plus 4 times 3x minus 4. So the answer was D. Okay, this is our second break. You'll try some problems on your own. Okay, next part is solving. So we only do a couple problems before we get to our next break. Here, I want to isolate the x plus 1 squared. So my first step, I'm going to add 5. So I get 3x plus 1 squared equals 9. Divide by 3, I get x plus 1 squared equals 3. Take the square root. You got to do plus or minus whenever you take a square root. So plus or minus the square root of 3 equals x plus 1. Subtract 1. Get negative 1 plus or minus the square root of 3. So the possible solutions you're going to look for on our list are negative 1 plus root 3 and negative 1 minus root 3. The one that was there was B. On question 9, we need to isolate the square root. So I'm going to add 2. That gives me square root of 2x plus 1 equals 9. To undo a square root, we square both sides. 2x plus 1 equals 81. Subtract 1, I get 2x equals 80. Divide by 2, x equals 40. Okay, this is our next break, so do the problems that are on the next part. Okay, now we're looking at techniques for solving quadratics. So one of the techniques we learned was completing the square. So if we're going to be completing the square on this problem, we have x squared minus 8x equals negative 1. The term I'm going to add to both sides of the equations, I'm going to take half of negative 8, square it, which is negative 4 squared is 16. I add 16 to both sides. The correct answer there was E. 11, this is using the quadratic formula. So first I've got to make sure it equals 0. So 2x squared plus 5x minus 1 equals 0. A is 2, B is 5, C is negative 1. So I do negative of B, so it's negative 5 plus or minus square root of 5 squared is 25 minus 4 times A, which is 2, times C was negative 1. I get negative 8 times negative 1 is 8 plus 25 gives me 33. So I'm going to look for either negative 5 plus square root of 33 over 4 or negative 5 minus the square root of 33 over 4. C is the one that matches. When we go to find the vertex, there's two different ways you can actually do this problem. Find the vertex, I could do it by completing the square, which we just did a little while ago. First, if I'm going to complete the square, I'm going to add 5 to the other side. So I have y plus 5 equals x squared plus 4x. Take half of 4 is 2, square it, add to both sides. So I added 4 to both sides. Get y plus 9. This will factor to x plus 2 times x plus 2. So I get x plus 2 squared. Subtract 9. I have x plus 2 squared minus 9. My vertex is what makes this part equal 0. So when x equals negative 2, when I plug in negative 2, I get 0 squared minus 9. That's negative 2, negative 9. There's my vertex. The other choice, you can also do it just by factoring this directly, and it's going to be halfway between the x-intercepts. So I could find the x-intercepts instead. This factors to x plus 5 and x minus 1. So the x-intercepts are going to be at negative 5 and positive 1. The vertex happens halfway between it. So if I average those two numbers, negative 5 plus 1 is negative 4, divided by 2 is negative 2. My vertex at negative 2, I take negative 2, plug into my equation. Negative 2 squared is positive 4. 4 times negative 2 is negative 8, minus 5. 4 minus 8 is negative 4, minus 5. The y-coordinate then becomes negative 9. So there's more than one way of doing that problem. If we're only going to have one x-intercept, it means we're going to be a perfect square. So for example, this one, the only x-intercept happens at x equals negative 3. On this one, this factors to x minus 2 times x minus 2. The number is the same, has one x-intercept. This one factor to x plus 5 and x plus 1. My x-intercepts are at negative 5 and negative 1. This one has x-intercepts at negative 2 and positive 2. This one does not factor. This one does not have any x-intercepts. Okay, that's our next break. So do the sample problems that are given. Okay, now we're getting back to our review of some of the geometry concepts we did earlier. Okay, so if I'm looking at my parallel lines, what I want to do is think about how they're big. I want to figure out what this angle is here. So I see my parallels. So I'm going to highlight those and then draw the line that connects with the angle. Well, I'm not using anything down here then. That's what I want to be aware of, because that is not part of the angle and these two lines are not parallel. So if I want to figure out what's going on, well, this angle here is 62. I could slide him over. That makes this one 62. A and C form a linear pair, so they're supplementary. So 180 minus 62 is 118. That's how we got the answer of B. For this next one, I'm going to use the idea of vertical angles here. That's 33. Corresponding angles, I slid the 102 up to here. These two have to add to 180, so that's 78. 78 plus 33 plus x equals 180. So 111 plus x equals 180. Solving for x, I get x equals 69. So the answer there was C. On this one, we have an isosceles triangle. So the angles opposite the equal sides are going to be congruent. So if this side's 2x minus, this angle's 2x minus 15, this angle's 2x minus 15. So if I add up all my angles, I get 2x plus 2x is 5x. Negative 15 minus 15 is negative 30, plus 5 is negative 25. Has to add to 180. Solving it, I'll get x equals 41. They want to know angle D, so I got to do 2 times 41 minus 15. That ends up being 67. So the correct answer was 67. Okay, this one, we're looking at the measure for angle TRP. Angle TRP is this angle that's right here. So I got to put both those two angles together. Well, one thing I can see, if this is a right angle, then these two have to add up to 90. So 3x plus x is 4x plus 18 equals 90. Subtract 18, I get 72. 72 divided by 4 is 18. So that makes this one, 3 times 18 is 54. 18 plus 18 is 36. This angle here is 90. I want TRP. So 90 plus 54, 144. For 18, I got to think about, it has to have at least one right angle and reflection symmetry. So, which means reflection symmetry means I can fold it over on itself and it will lie right on top of itself. Well, if I look at a rectangle, it has 4 right angles, so I get the first condition, and I can actually fold it across this way or across this way. So I've got a couple lines of symmetry there. Isosceles triangle, there's no right angles. Right trapezoid, okay, I got a right angle, but it has no reflexive symmetry. There's no way I've folded on top of itself. Parallelogram doesn't have to have a right angle, so I'm just done there. Square, okay, 4 right angles. All the sides are equal, so I can actually have lots of lines of symmetry. I can fold it across this way, fold it across this way, across the diagonals. All those will work. So A and E. Okay, when you're working with triangles, and this is basically working with the triangle inequalities. Okay, in order to form a triangle, the two smallest sides have to add up to be bigger than the largest sides. So if I use this side as 4, the two smallest sides be 4 and 8. 4 plus 8 equals 12. That's not bigger than 12. So 4 doesn't work. 8 and 5, this would be the next one. 5 plus 8 is 13. That's bigger than 12. That one works. Next one, if I have 8, 10 would be my next smallest. 18 is bigger than 12. That one works. Then if I take 20, well, that becomes the biggest. So if I do 8 plus 12, that equals 20. That's 20 is not bigger than 20. So D doesn't work. And 20 is certainly not bigger than 21. For problem number 20, what you need to do is draw out a triangle, fill in your angles. So we told that angle A was 68, angle B was 40. Add these together, I get 108. Subtract it from 180. My missing angle is 72. Your largest side is opposite the largest angle. So my largest side is AB. My smallest side is going to be AC, and the one in the middle is going to be BC. I want to go from smallest to largest. Smallest is AC. Then my middle one is BC. Largest being AB. Answer was E. Okay, that's your next break. So do the problems that are coming up. Okay. For this next one, we're going to look at our basic proofs. And we're going to be filling out all these different rules. So there's a lot of different problems for this one diagram. So we're going to kind of fill it in all up here, then answer all the questions. So first thing I'm going to do is mark up my figure. Angle T is congruent to angle P. So mark those. Side TD is congruent to PA. I'm trying to prove that RD is congruent to RA. So those are my two givens. Next thing I got to use is like for vertical angles or reflexive. So this angle equals this angle. Those are vertical angles. So what I've got to do is make sure I have R in the middle. So if I did TRD is congruent to PRA. That's because of vertical angles. The big thing is I'm looking for the fact that R is in the middle. So that's why that one was B. For 22, I'm going to put these pieces together. Well, what I've got is I've got an angle. I've got this side. Got this angle. So that's where we're going to go over work with it. But on my figure goes angle, angle, side. So make sure it's angle, angle, side is what our solution is going to be. So that's going to be the reason for 23. For 22, I've got to make sure I get a correct congruency statement. So when I go to do it, I got to make sure that T matches P. So triangle T congruent to triangle P. So I might figure out what I have right here before even looking at what the answer was. R is going to match R. And then angle D has to match angle A. So that's what I'm looking for. I'm looking for T matching P, R matching R, D matching A. So if I go down here at these problems, T matches P, D matches A, R matches R. So the answer where was C. Then, reason for 23, again, you look at your figure, not at what happens up here. You look at here. This is angle, angle, side. Then finally, the reason why these are congruent. Once you've shown congruence, then there's two different ways you can actually write it. You could do congruent triangles, leads to congruent parts, or you could also see it as CPCTC. So both those are accepted. Congruent parts, congruent triangles are congruent. Okay, so let's look at another idea of congruence. It's going to mark up the figure and then figure out what else do we need to be able to show it's congruent. So JL is congruent to PR. JL, PR. KL and QR. KL, QR. Okay, so different ways I could do it. One way to do it is I get the third side. So if JK was congruent to PQ, I'd have side, side, side. So that was E. And then I also, if I'm going to use an angle and I have two sides, the angle has to be between. So angle L has to match angle R. So that would be C. Okay, this is our next break. So go ahead and do the problems that are coming up. Okay, problem 26 and 27 is on similar figures. Okay, if I'm going to go over solve for x, I need to match up pieces from my figures. So I know these two figures are similar. So I look at the angle marks. This side, this angle, matches this angle. We have a double mark one here, matches this. So x is between those two. X has to match up with 10. So I might do x over 10, if I do large one to small one. Now I'm going to look at matching something else, but I've got to go consistent. 18 is the one with a dash and a blank one. There's nothing here, so I can't use the 18. So I go to the 9. 9 matches, well, I've got a single mark and an empty. Single mark and empty is the 6. So if I look at that, that one ends up being D. You might see different combinations if you're not sure. Cross multiply, and then it'd be the same as a cross multiplication. So it has to be 6x equals 90. So I can check which ones will be give me 6x equals 90. Or if I solve it, I'd have to solve it all the way out. It'd be 15. I know with x equaling 15. Okay, proving. We have three different ways of proving two triangles are similar. Angle-angle similarity. That's this one. Side-angle side similarity. And the other one is side-side-side similarity. So it can't be this one, because that's not a reason. So now I'm going to look at what we have. Well, I have a side, and an angle. So I can't use either one of these two. I don't have it. So I'm not going to be able to say yes. So I can eliminate A, and I can eliminate B. Now there's two possibilities right here. They might still be similar, but if they were similar, then the sides have to be proportional. So if I do the small side to small side, 6 over 9, that's 2/3. The next largest side is 10 and 12. 10 over 12 is 5/6. These don't match. So these figures are not similar because they have to match. If they were, they might be. Now, so it should be, no, they are not similar. The correct answer was D, not E. So the correct answer there was D. They are simply not similar. If they end up being the same ratio, they are both through 2/3, well, you cannot determine if they're similar or not, because I might not have my angles matched up, because I could take this side and like swing it over here, do weird things like that. So I don't know what's necessarily going to be happening with it. So we're not sure how the triangle is actually being formed. I should probably 10 over the other side. Okay, that's your next break. We'll have just one similarity problem to do, and give that a go. Okay, now we have some probability and expected value. Okay, so we have a varsity football team has 43 players. The total, when I add up everything, is 43. 28 players are seniors, so I know this total has to be 28. 12 are juniors, and then 3 are sophomores. So if I add up all those numbers, it adds up to 43. Then 10 of the seniors play both. Whoops, 10 of these seniors. I put this one in the wrong spot. 10 of the seniors, if I make this one sophomores and this one seniors, 10 of the seniors play both ways, which means 18 don't. The juniors, 6 of them can play either offense or defense, so that means 6 don't. It says all of the sophomores go both ways. So they both play offense and defense. I want to find the probability of selecting a senior. That's all of these. Or somebody who plays both offense and defense. That's plus these. So I've got 28 plus 9 is 37. out of 43. That's how I got D. Okay, for expected value. Well, we have 120 degrees right here. The fraction of the circle we have is 120 over 360. That reduced to 12 over 36, which is 1/3. So 1/3 of the time I should get a 6. 90 is this one. That's 1/4 of a circle. So 1/4 of the time I'll get this one. Now, if I do 90 plus 120, that's 210. Subtract that from 360. This angle is 150. 150 over 360, that's 15 over 36. That reduces to 5/12. So my expected value, 5/12 of the time, I'll get 24. 1/3 of the time, I'll get 6. And then 1/4 of the time, I get 8. So 24 divided by 12, that equals 2 times 5 is 10. 6 divided by 3 is 2. 8 divided by 4 is 2. I end up with 14. Okay, then we have a club is selling box chocolates. Small boxes go for 12, large boxes go for 20. 80% of the sales were large boxes, so that means 80% were large. They get to keep half of all their sales. I want to know how much money should they expect to make per box. Well, I could do it a couple different ways. I could figure out what they make total money and then divide it by 2. Or divide these by 2 to start. So they're making $6 a box for the small ones, and they're selling 20%. They're making $10 per box on the large boxes, and that's 80%. Then add them together. So 6 times 0.2, that's 1.2. 10 times 0.8, that is 8. 8 plus 1.2 is 9.2. So they make $9.20 per box. Okay, so that's your next break. Okay, for the next part of the problems, we have systems of equations. So what we're going to try to do is we want to go over and see about eliminating, or you could actually even solve for y if you wanted to, but I think the easiest way of doing this particular problem would be multiplying by 2, because that will give me 8x minus 2y, negative 46. I add these two together, I get 11x. 2y and negative 2y cancel out. Negative 9, negative 46. X equals, we got negative 55. Divide by 11, you get x equals negative 5. So that's one of my answers. To find the other answer, I plug in negative 5 into either one of these equations. So 3 times negative 5 is negative 15. Add that to negative 9. I get 6 divided by 2, and I get 3. Okay, the main part of this section actually is on parabolas. Okay, so x-intercepts. To find the x-intercepts, I've got a factor. So this one factors to x plus 2 times x minus 3. We got x equals negative 2, x equals 3. So my intercepts are at negative 2, 0, and at 3, 0. For a parabola to open downward, the square needs to be negative. This one opens up, this one opens down, this one opens up, only touches one spot in the parabola. This one, when I square a negative, becomes positive, so it still opens up. That negative causes this to open down. So if I multiply this out, I'd get a negative x squared. Okay, so now I want to figure out which could be the equation of a parabola. When I look at my intercepts, this one happened at negative 2, so that's at negative 2. This one right here is at negative 6. So those are like solutions to my equation. So that means I have x equals negative 2 and x equals negative 6. That means it would have had x plus 2 equals 0 and x plus 6 equals 0. So my factors are x plus 2 times x plus 6. If I multiply this out, I'll get x squared plus 2x plus 6x, 8x. 2 times 6 is 12. Okay, that's our next stopping point. So you're going to do the problems on parabolas, and then we'll look at trig stuff. Okay, on this one, right here, first thing you want to do, if I have one of the angles, I can figure out the other. So I know that 23 is this angle. This angle has to be 67 because the sum of the angles in a triangle. We want to know what can we use to solve for y. It says all equations. Anytime you see the word all, look for two answers. It could be only one, it could be three, but almost always it's two answers. So that's kind of your hint. Look for two answers. Okay, well right here we have opposite and hypotenuse. So if I did sine of 23 is equal to 5 over y, that's one of them. This side, if I look at the 67, the 5 is adjacent and the hypotenuse. So it's cosine of 67 equals 5 over y. That would be my other equation. Tangent, I would need to have opposite and adjacent this side, or opposite and adjacent that side. Okay. This one's about finding angles. When you have to find an angle, you've got to use the inverse. So I look at what I have. This is the angle I've got. I've got the adjacent side and the opposite side. This side's the hypotenuse, so it's not a bad idea to label where the hypotenuse is. Opposite, adjacent. So that means tangent of A is equal to 10/3. To solve this, I got to do inverse tangent. So I do tangent inverse of 10/3. That answer was C. For this triangle, this one's a little harder. It takes a little more thinking. Tangent of theta is 3/4. So I put a triangle here so you can kind of build it. So that means opposite side is 3, adjacent side is 4. Then I could do 3 squared plus 4 squared is equal to C squared. And you should recognize that's kind of a special triangle. It's called 3-4-5 triangle. It's a Pythagorean triple. So I got 9 plus 16 equals C squared. C squared equals 25. This side is 5. Okay, so if I use my other ones that I can have, if I want to use sine, sine is opposite over hypotenuse. So sine of theta is opposite, which is 3 over 5. Cosine is adjacent over hypotenuse. That's 4 over 5. So I've been A and D. Using Pythagorean theorem again, we have the two sides that are connected with the right angle are going to be one side of my equation. This one's on the other side. So it's x squared plus 6 squared equals x plus 3 squared. So I have x squared plus 6 squared equals x plus 3 squared. When I square this, I get x squared. Then multiply these two together and double it. 6x. 3 times 3 is 9. Now remember, if you have trouble with this, you can FOIL it out. It's x squared plus 3x plus 3x, and 3 times 3 is 9. So that's where the error usually occurs for most students. Subtract x squared from both sides. I get 36 equals 6x plus 9. Subtract 9, divide by 6, you get 27 over 6, which equals 9/2, which is 4.5. Okay, then we have our special triangles. That's what the last two are on. Special triangles are our 30, 60, 90s and 45, 45, 90s. So for a 30, 60, 90 triangle, the pattern went n root 3, and 2n. This is opposite the 90. So 2n equals 6. So n equals 3. So opposite the 30 is 3. Opposite the 60 is 3 root 3. Opposite the 90 was 6, which was given. So my other two sides were 3 and 3 root 3. For this last one, we're going to have to use a combination of things. 45, 45, 90. The pattern is n root 2. Well, I have opposite 90 is 10 root 2. So for this small triangle here, these two sides are 10. So this side's 10, that side's 10. Now I'm going to look at this triangle so I can figure out what x is. So again, 30, 60, 90. Opposite of 30 is n. Opposite 60 is n root 3. Opposite 90 is 2n. So opposite 30 was 10. Opposite 60 then is 10 root 3. Opposite 90 is going to be 20. Well, if this angle here is 30, this angle up here must be 60. So x equals 10 root 3. So the answer there would have been A. Okay, we have one last problem to work through, and that finishes off the review.